Okay, some tips to use so that you aren't as stressed out when trying to do this math in your head when you're estimating are to round in a way that will make the calculations easier to do for you. And it's going to seem like you're just faking it and making up numbers, but it's an estimate anyway. We're really just after the nearest order of magnitude. So for example, 3.7 times 12.94 times 10 to the 3 times 1.4 times 10 to the negative 2 divided by, I'm just making up a bunch of numbers, 4 times 10 to the 8 times 0.05. Just leave it like that. How am I going to estimate this in my head? It looks like a horrible calculation. I would definitely generally want to go grab a calculator to be sure of the answer, right? But when you're doing a Fermi estimate, the whole point is to do it quickly, to get a fast answer. So don't grab a calculator. Well, take a look at it and round anything that just seems obvious, like 12.94. That's really close to 13. I'm estimating nearest order of magnitude. These two digits are not going to change that much. I'm just going to drop those and leave it as 13 times 10 to the 3. Then, so I got rid of that one. 3.7, and if I look around to the other things, I see there's a 4 on the bottom. And this is 3.7, and I'm dividing. So if I change that one on the top to 4, the 4 on the bottom is going to be really easy to divide by, because I know that I see a 4 here and I'm dividing by a 4 there. That's good. It doesn't matter that this one is 4 times 10 to the 8, because that's multiplication. So as long as you can, as long as everything on the top and the bottom, like this calculation, is multiplication or division, then you're fine canceling out the 4's like this. 1.4 over there, and I got a 0.05. I don't know. Another way to write 0.05 would be to move the decimal and just make it a 5. And so that would be 5 times 10 to the negative 2. I don't know where I'm going yet with this. Here's a 1.4 times 10 to the negative 2. If I round that down to 1, it's certainly easier. Yeah. Or, you know what? That's really close. I got a 5 down here on the bottom, and that's 1.4. If I change this to 15, which by moving the decimal one time, and rounding that number to a 5. Not even rounding, it's just changing it to a 5. This part of the number got bigger by a factor of 10, so that part has to get smaller by a factor of 10, so that's 10 to the negative 3 now. Now if I look at this, 15 divided by 5, that's easy to do. 15 divided by 5, that just becomes a 3 up there. So now I've got 3 times 13. That's not too hard to do in your head. You could just, if you can do it in your head and it's easy and you don't have to really stop and think very long, then do it in your head. You don't have to change everything. So 39. 13 times 3 is 39. There's a 10 to the 3 here and a 10 to the negative 3 here. So that's 10 to the 3 times 10 to the negative 3. That's just 10 to the 0. Times 10 to the 0. So I'm done with the top. The bottom is, there's still a 10 to the 8 and a 10 to the negative 2. So I'm dividing by 10 to the negative 6 down there. So when you multiply powers of 10, remember, what you're really doing is adding the exponents together. 8 plus negative 2, that's 10 to the 6. I just called a mistake. It's not 10 to the negative 6. It's 10 to the 6 down there. Now, 10 to the 0 divided by 10 to the 6. 10 to the 0 divided by 10 to the 6. That's the same thing as 10 to the 0 minus 6, or 10 to the negative 6. So the final result here is 39 times 10 to the negative 6. Now I went slow and wrote out a bunch of steps. Ideally, when you get a little better at this, you don't have to write out as many steps. You can kind of just do it all in one go, maybe. And there's a final number. Now, what is it really? If I didn't do any estimation, let's see how close I get. 3.7 times 12.94 e to the 3 times 1.4 e to the negative 2. I'm going to divide by 4 e to the 8, and then divide again by 0.05. What is this? 3.3 times 10 to the negative 5? Okay, well look at my answer. If I move the decimal 3.9 and make this part smaller by a factor of 10 so I can make this part bigger by a factor of 10, that's 3.9 times 10 to the negative 5. The actual answer is 3.4 times 10 to the negative 5. Like, this is really close. This is good. This is a great estimate. And I didn't need a calculator. And it was a little slow, but that's because I was explaining literally every step along the way, right? So get into the habit when you're doing these estimates, or even when you really want to calculate anything, of thinking about the powers of 10 separately from the rest, and thinking about the numbers in front of the powers of 10 separately from the rest. So split it up into those two things, and then rounds in a way that makes the calculations easier to do. Enjoy.